So today I'm going to review what's in this box here, which apparently is an installation resistance tester. This has been sent to me by Banggood for free. Let's check it out. Got a pouch. And here we go. So we've got some cables here. Another cable here to like a clip lead. There's the actual tester. And we've got a couple of manuals. One's in Chinese and one is in English. Get it on screen. Can you read that? Read that in your own time. Okay. Specs. 5% accuracy plus 10 counts on voltage. It's not exactly wonderful specs. That's output accuracy and full resistance. So I'll show you this bit so you can get a better idea what we're talking about. So there you go, there's the specs we care about, most likely. So we have this model here. This one we've got, the 2,500 volt version. You've got a 1,000 volt, 2,500 volt and a 5,000 volt version. We have on the bench the 2,500 volt version. That's the one we care about is right there. So as far as the leads go, let's have a look at what we've got. You have to excuse the voice, I've got a cold right now. I'm just getting over having COVID. I just started feeling kind of okay again, and I caught a cold with my wife. So I've basically been sick now for 3 weeks straight. It's getting a bit tiring. We've got some crocodile clips, but you get different qualities of these things. Some are better than others. And these ones actually have this threaded insert in there. You get the probe, which has got a thread on it, and you would thread this on. So instead of just being a push fit, it's actually threaded on to the actual fitting. So that seems alright. Looks like it's crimped. I don't know how good these actually are in reality. It's like some reasonable crimp, I suppose. I don't know. That's why it's insulated as well, because it's all high voltage stuff. So these are just PVC leads, they're not silicon. I prefer silicon leads on things really, but yeah. And this one here is like a grounding connection for doing testing. Also PVC leads. It's all the same sort of thing really. That's the cables. So let's look at the meter itself. So we've got 4 connections here, which is interesting. You have a test button, up and down options, hold and backlight, selection, memory read, because it's got logging into it as well, and PI and DAR. DAR is dielectric absorption ratio. PI, I can't remember what that is right now. So what this basically means is you can do a high voltage test for a period of time on a cable or something and see the dielectric absorption of that material, which is actually a measurable specification. So you can actually determine if a material will break down under high voltage over a period of time, rather than just it's okay for 10 seconds, is it still okay after 10 minutes? That kind of thing. Okay, the battery do have a tilting barrel, which I pulled out, but what I don't like about this, to get this out, you've just got a tiny little slot you've got to try and get your fingernail into, right? That's not easy. I mean, if they had a bigger cutout here, or even a little piece on the back to actually allow you to grab it, I mean, I don't know why I've got this recess here. If that recess went the other way round, it'd be easy to get it out. It's kind of the opposite of what you want. Yeah, anyway. If you've got a screwdriver, I'm sure you're jamming in there just fine. So 600 volt Cat 4. It does AC and DC measurements from 10 volts to 600 volts. Output for 250 volts to 2,500 volts. Like I said, there are different versions. The 1000 volt version does a 50 volt test. So they've got some different ranges. And you've got, basically, these are for measuring voltages. Those two there. And these are for doing the insulation resistance test. Those ones there. I have already put batteries in it, and I have already turned it on once. Let's see where we go. And I shall jam these probes into a PowerPoint, because why not? Like I said, I believe these are the measurement terminals. Measurements, here we go, AC voltage measurement. Turn the power supply on, well, there's a source on. Jam the terminals in. I've got 2 displays there, one says 229, one says 227, this says 229, I believe it's 229. So that's obviously working alright. Next selection, it does DC voltages. Now I don't have a high voltage DC, well I do, but not here, right now. So let's just get a DC source. There you go, let's turn that power supply on, that's doing 20 volts. I believe it should be able to read that. Let's jam those in here. Doing 20 volts, and yep, seeing 20 volts on display there, so that's fine. That's obviously working alright. You wouldn't expect any less, would you? And the next selection is going back to insulation resistance testing again. So we've got hold here, which holds a reading, and you hold it down, backlight turns on. You can't see it too well with my lighting here, but you'll probably be fine. When in situations where you need a backlight, you're probably looking just fine. PI and DIR. Let's change this setup to be insulation resistance testing. So I have a mains cable hooked up over here, clipped onto the plug. It's got bare end wires here, not connected together. And we'll do a test. No leakage. That's what you want to see. Okay, let's try 500 volts. No leakage. 1000 volts. No leakage. 2000 volts. Well, we're seeing a little bit there. There's some leakage there, look. 37 gig. 2500 volts. There you go. You get 1.8 giga ohms of resistance there. I think that's reasonable though, don't you? But yes, 2500 volt test on a cable. I think it's fine. So that cable there, that passes absolutely fine. Now these things, because they are high voltage, this does light up red when it's doing a test. See that? My lighting kind of hides it. In daylight you probably wouldn't be able to see that. It's not very obvious. So let's try a cable which probably isn't suitable for high voltage. This is an audio cable. Let's try that one. I've hooked up to one of the conductors on this thing. It's an inner conductor and an external shield it's got on it. So it's really thin insulation there. So 500 volt test, let's start that one. Nothing, that's fine. 1000 volts, it's fine. 2000 volts, still fine. Oh, there we go, we're starting to see something there. Let's go 2500 volts. And surprisingly we're getting gigaohms. That's actually doing quite well. I'm really surprised by that. I thought it would be much lower. Interesting. Okay. So let's try in between shields of different conductors. So let's go between those ones. Here you go. 4 gigaohms. A bit different. And let's try between this other one. Oh no, that's showing a short. That was broken down. Okay, let's try low voltage. Short. And that's between a red and a white. So like the shields and those ones are touching together. So that's not surprising, that's actually correct. So if I do that way, it should be fine. Yep. So that's a short then, because the shields are twisted together for the red and white. So yeah, that worked. Just do that again, low voltage. Takes a little while to react, but it does actually show a short and does beep. But yeah, okay, well that works fine, doesn't it? So the pi mode here, that's polarization index. So right now I'm doing a test with DAR, and I believe after 1 minute it should stop. We'll give a reading or something, there we go. That's the reading for DAR. Now if I want to do PI, it's a 10-minute test. Let's try that, shall we? There's a relevant chart. So this is for PI, which is what we're doing now. It just takes a 10-minute test. So after 10 minutes it will stop. And it's got ratios, and you have to be above a certain level to be considered okay. Alright, so these are just examples here of what it considers to be a bad problem. Like if you've got less than 1, then you've got a problem. But you want to be higher is better, basically. The same for DAR as well. That's a 1 minute test, which we did before. We got 1.24, so that's towards the top end. So that's a good DAR reading. So we're going to do the PI run, let that run for 10 minutes, and we'll see what we get from that one on the same cable. Well, it's been nearly 5 minutes and it's still going. Whilst we're waiting, I'll compare it to this one. This is my samurai meter. I've had this one for about, I don't know, maybe 20 years. I don't know, I've had it a long time. And this is another standard version of insulation resistance tester. You know, it just does 250 up to 1000, so it's less capable in that way. So battery test shows its battery needs replacing. It's just about on its last legs. But this is what I've been using up until now, is this thing. I don't do much installation testing, but I do on equipment occasionally. When I'm repairing equipment, I need to check things or check cables, things like that. So that's what I use this thing for. And so I've had this thing for quite a long time. But it also does AC and DC measurements as well, but it does AC up to 600 volts only and 60 volts DC. So it's a bit more limited in that way, but this has done me quite well for years. So my wife picked up from me recently. It's a pure coincidence, my wife picked this up for me. She was at a charity store thing. She goes looking around for, interesting things, and she found this case, which is what's sitting in the background there. I opened this up, you see it's got a meter in it. Now let's open this case right up. It's an original Mega. I haven't tried it yet, don't know if it works. It's an interesting little thing. There you go, there's a display on that. Goes at 100 mega ohms, or infinity of course, down to 0. I've got no idea what year this was. It's got terminal on the side here. Basically what you do is you squeeze this and it opens that up and you can clamp cables in. And both sides it's got ohms and mega ohms reading there. We'll switch for that, and it's got this wind up thing on the side. You get this and you wind it up. So yeah, I haven't tried this yet. I don't even know if it works. I mean, when I wind it you can see the meter moves, so there's something going on. But this would be an interesting thing to look at one point. Weighs a ton. It must weigh like a kilo or something. It's really heavy. Alright, just about to finish a 10-minute test. We'll see what we get. There we go. You got a PI of 1.02. That's interesting. So if we look at the chart for that, warning. That's interesting. Is it because I didn't get a actual resistance value there? Did I only get a 102 because it's it didn't actually have a resistance? It's just open basically. It's infinite resistance because it's above its reading scale. Maybe that's what I needed to do, is get a reading scale from that. I'm not going to do it again. I'll do the DAR one again. I've shown both there, we go. So DAR was 1.11 and the pi was 1.02. A 2,500 volt test, and I'll do DAR of that. And we'll see what comes out of that one. I'll come back when it's done. So I did DAR again, and this time we got 0.98. Interesting. So it's actually less than 1, which means it's not an ideal value. That's curious. I think this cable's bad. But is it? So apparently we got this logging system, I suppose. It's kind of a logging system. You have to manually store things. If you choose to do that, you don't have to do it obviously. But I think you have to put it in hold first according to the manual. I haven't tried this yet myself. And then you push this button. And you push that button. Do you see a symbol popping up? Oh, maybe I have to hold it down. I don't know. Anyway, it's got a memory system in there. I don't know, use it. If you buy one of these, maybe you can figure it out and put it in the comments. Right, so I just did another measurement, just a brief one. Pushed hold. Apparently I should better push this. No. Yeah. I don't know. I can't get this to actually work. I don't know. I can't figure out from the instructions how to make that work. So push this now with nothing there. There's nothing coming up. For long press, no. I don't know. I followed the instructions. I can't get it to work. I don't know what happened there, but I did select, right? So I went around AC/DC, back to insulation resistance test. Then I pushed the button, and it's got something there. It does work. I just got to figure out how to get into it. Maybe some kind of bug in the firmware, I'm guessing. Let's go right back around again. We'll do another test just to generate a result. Okay, we've got something. Hold it. Stop. There, it's held on screen. Hey, it's done something this time. It's going to read, not save. Ah, there we go. Now it's done it. It doesn't quite work the way the instructions say. I don't know, just randomly push buttons till it works. It works for me. So there we go, we've got a memory save now, number 3. There's number 4. Oh, I can choose which one to put it in, can I? Can have it up to 100, apparently. So I think I've saved it in about 3 different slots. There you go. Somehow I've saved it in multiple slots. Yeah, okay. Apparently you can delete it by pushing that. That bit works. With that bit. Cool. So apparently it's got 100 slots in here, and so you can save readings if you want to reference something later on or have evidence or something, I guess, I don't know. Press and hold that down to accept. That works. Yeah, so there's something a little bit weird there in the firmware where it doesn't quite get in there under a certain mode. Maybe if I've got this PI DAR on, maybe if that's on, it's causing a problem. A bit of frustration getting there, but hey, it does work. You just have to learn how to use these things. Yeah. Next time I go to use it, I would have forgotten. So we haven't checked the accuracy of resistance ranges yet, so let's quickly do that. I've actually recorded a video and finished it and edited it. I thought, actually, I haven't done any resistance checks to see what the accuracy actually is. Now, because this is high voltage, I'm not going to put this on my calibrators. I don't know what's damaging those precision resistors. So I'm just going to use some standard resistors and do some comparisons. So here on the Fluke, I can get you 1.527 meg, and we'll see what we get in the 250 volt range of this. Let's do a test. It just says it's a short. 1.5 meg, can't read it. It could be breaking down across the actual resistor. It's possible. Let's try a different resistor. Because it is high voltage, so it could be bypassing and basically skipping across the surface of the resistor. It's possible. Oh, I need to measure this one. Let's see what it says. 1.522. Also it sees it as a short. It's 1.5 meg. Can't see it. Okay, let's try a larger value resistor. This is a 10 meg, I believe. We'll find out in a second. So we can measure it. 10.27. Hey, look at that. 10.28, 10.27. Perfect. So I can actually read that one absolutely perfectly, and it's bang on. Lovely. Right, so it's a 2.7 meg ohm. Yeah, 2.67. .69 on that one. Okay, let's say 2.69. Yeah, so there's a bit slight discrepancy there, but it could see that one at least. So I couldn't see 1.5 meg ohm, but I could see 2.7. Wonder if that 2 meg ohm is the limit or something. Anyway, it looks accurate enough for those measurements. I've got a 4 meg 7 here as well. Yes, I'm holding one of the leads. It shouldn't matter because I'm only holding one side on the bench, because that shouldn't matter. Here you go. 4.98, that's what we're getting in that one. 4.95. Seems fine. I mean, don't forget the specs were like 5% or something like that, plus, was it 10 counts? That's well within spec. So let's go back to the 2.7 meg resistor. Should we see if we can find a breakdown voltage for that? So let's go 500 volts. 2.7 meg. Okay. 1000 volts. 2.6. We're getting a little bit of leakage there. Or it could just be an accuracy thing. It is creeping downwards. 2000 volts. And now we're seeing a dead short. But that could just be the way this thing does the ranging. So, inconclusive. In fact, this resistor, when I took it off, it's slightly warm. And I just measured it on the Fluke. I'll show you again. Can't touch both sides at once. 1.3 meg. It killed that resistor. So yes, it was leaking. I wonder how hard it is to pull it apart. How hard it is to get this rubber bushing. How hard is it to get the rubber baby bugger? Baby rubber baby bumper thing. I wonder how hard it is to get this rubber casing off to get into it. So it's not actually rubber, it's PVC. By the way, it's PVC. It feels very different. It's plasticized PVC. It's a tight fit. Here we go. Got to try and do this without ripping the bloody casing, because it could still rip. There we go. feels like plastic screws. Yes, it is. But then that shouldn't really matter. It's not like something you should actually get into often anyway. You know, or maybe even ever. I don't know, it might have internal fuse in it maybe. But yeah, it's not something you'd normally get into, so I'm not too worried about having threaded inserts in this particular part of the unit. There's one there, but here's that little thing there. Let's get the battery cover open. Battery cover is a threaded insert, which is where you need it to be. It takes 8 AAs. Let's pull this apart. So this is the battery holder that side. So that's what's in there. Not a lot to see really, is there? Transformer. We've got a ladder network here, so you've got capacitors and diodes. So this is a voltage multiplier. We've got a whole bunch of MELF resistors here, which is obviously for voltage sensing. Because each one's rated for, I don't know, 250 volts or something like that, each one. Maybe 500 volts, I'm not quite sure what the MELFs are rated for. Yeah, that's why there's a serious chain like that, so you can do measurements. So there's not much in there. You've got a blob chip.
Blobby, blobby, blobby!
You've got the terminals here going to the top. I don't know, what is it to say about that? It's what I expected to see in there. If you had like one of the other models, like the high voltage model for example, maybe have one more step in the chain. May do. Possibly. There's a PTC up there as well, protection. Series resistor, 3002 is that. A bit of output protection. Not much to see. It is what it is. Let's put it back together. And I just know someone's going to comment on the fact I've got mixed batteries in here. I measured the battery voltages to make sure they're all very similar. I didn't have enough batteries to populate this thing fully with one set. Now, the scariest thing about doing this mixed batteries is I've got a drawer cell in here. That is the only dodgy bit about doing this. There's a drawer cell. That's the dodgy thing. They always leak. The thing I don't understand is how I even have a drawer cell, because I don't buy them. I guess I got it out or something. I don't know. I'm going to put this to one side. I never leave batteries and things if I don't use them very often, which is why I'm taking the batteries out, because I don't intend to use this again for a little while. So take the batteries out of things, people, especially if you've got one of these in there. Right, it's all back together. Probably still works. Don't forget to check out the links down below to go down to Banggood. Check out the purchase links or more information if you want to find out more information about these. Pricing wasn't too bad, I think. And thanks a lot, Banggood, again for sending me this at no cost to do a review on it. Other videos down below. Subscribe over there if not already subscribed. Patreon support link over there. If you want to help support me on Patreon, help me to buy bits of test gear to do repairs on and make videos about. Catch you later.